Assalamu alaikum everyone. Welcome to another video of Chemistry with Saripta Sambe. In this video, we are going to start our new chapter, Chemical Bonding. When we talk about chemical bonding, there are three sorts of bonding in our syllabus. When I say the word bonding, these three words should always come to your mind. The first type of bonding is called ionic bonding, which we are going to discuss in detail in this video. The second type of bonding is covalent bonding. And the third type of bonding is metallic bonding. Let's look at the definition of ionic bonding. When I talk about ionic bonding, this definition is important from an exam perspective. So ionic bonding is described as the strong electrostatic attractions, and keep in mind that all bondings are electrostatic attractions. So ionic bonding is the strong electrostatic attraction between oppositely charged ions. In one of the previous videos, we saw that there are two types of ions, cations and anions. These oppositely charged ions attract each other via electrostatic attraction. Let's look at one of the examples. When I talk about an ionic compound called NaCl, now this NaCl is an ionic compound, which is basically the common salt or the table salt, which is also known as common salt or table salt, which is used in food flavorings. This NaCl contains two ions, the sodium cation and the chloride anion. Let's look into detail how the sodium and chloride electronic configurations look like. So sodium is 23 and 11. So the atomic number of sodium is 11 and the electronic configuration of sodium is 2, 8 and 1. We know that metals tend to lose electrons. It's easy for metals to lose electrons. So sodium will lose the one outermost electron it has, and sodium cation would look something like this, 2, 8, and we'll get the electronic configuration of neon. When I talk about a chlorine atom has an atomic number of 17. So this is 2, 8, 7. And since non-metals tend to gain electrons, chloride anion will gain that one electron which the sodium is losing. This non-metal will gain the electron the sodium is losing and will get the electronic configuration of argon. This is how the electronic configuration looks like. Let's look at the dot and cross diagram of NaCl. So when I draw the dot and cross diagram of NaCl, sodium has 11 protons in its nucleus, but around the nucleus it will have only 2 shells. The sodium atom will have 3 shells or 3 energy levels, but sodium ion, the sodium cation, will have only 2 shells because it has lost one electron and the outer shell is empty now. So the sodium cation will have a positive charge. The middle circle is the nucleus of the sodium ion, and it has a duplet, 2 electrons, and an octet, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. The cross represents the electrons of sodium, Na. Now let's draw the dot and cross diagram, the dots of chloride. So this is the nucleus of chlorine, the duplet of chlorine. Now chlorine atom also has 3 energy levels and chlorine ion also has 3 energy levels because chlorine is not losing an energy level in this case. So 2 electrons in the duplet, 8 electrons in the octet, and 8 electrons in the third shell, and chlorine will get an overall negative charge. This is how you make a dot and cross diagram of NaCl. Let's take another example. Let's make the dot and cross diagram of magnesium fluoride. So this is NaCl, dot and cross diagram, dot and cross. diagrams. Let's take another example of magnesium fluoride. In magnesium fluoride, magnesium is in group 2. So the charge of magnesium cation will be 2. Fluorine is in group 7. So fluorine can only gain 1 electron. So the charge of fluorine would be 1 minus. I need 2 fluorines to balance the charge of magnesium. I would need 2 of the fluorine ions to balance off the charge of 1 magnesium ion. So basically, I can simply find out the formula of magnesium chloride by cross multiplying their charges. So magnesium is 2 plus, fluoride is 1 minus. When I cross multiply their charges, Mg gets a 1 and fluorine gets a 2. So the formula becomes MgF2. How did I know that magnesium has a 2 plus charge? Because magnesium is in group 2. It has 2 outermost electrons. It can lose 2 outermost electrons and will get a 2 plus charge. Fluorine is group 7. So fluorine will gain 1 electron and that's why it gets a charge of 1 minus. So I need 2 fluorides. I need 2 fluorides to balance off 1 magnesium cation. So let's make the dot and cross diagram of magnesium chloride. Magnesium is 24 and 12, which means 2, 8 and 2. And the magnesium cation would just be 2, 8. Whereas fluorine is 19 and 9. So this is fluorine is going to be 2, 7. And fluoride anion would be 2, 8. So let's make the dot and cross diagram of magnesium fluoride. The first thing is the magnesium atom. So this is Mg with a duplet and then you have an octet of magnesium. So 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8. It's obviously a cation, so it will have a 2 plus charge. Whereas I need 2 of the fluoride ions. So fluoride ions I need 2. So first I'll make 1 F, the duplet of F, the octet of F, minus. It has gained a charge, this would be dots. Because I've made magnesium with crosses, so fluorine has to be dots. Fluorine has to be dots. So 1, 2, 3, 4, 5, 6, 7, 8. And the 1 electron of fluorine is coming from magnesium, so it's going to be across here. I think I made the same mistake upwards as well. These chlorine electrons will be dots. Let me make dots. Just let me make this again. Sorry. Okay. So 1. So duplet, 2 electrons. Then octet, 1, 2, 3, 4, 5, 6, 7, 8. And then the third shell will also have 8 electrons. So 1, 2, 3, 4, 5, 6, 7. And the 8th electron is coming from sodium, so that's going to be a cross. And then here, I'm going to make another fluorine ion because it's 2 of the fluorine ions. So 2 fluorine ions. 1, 2, duplet. And then 1, 2, 3, 4, 5, 6, 7. And the 8th electron is coming from magnesium. So the 2 electrons magnesium has lost, one goes to one fluoride ion and the other goes to another fluoride ion. Let's take a very small example of lithium nitride. Now lithium has a charge of 1 plus because it's in group 1 and nitrogen is in group 5, so it could gain 3 electrons. So this is lithium nitride. When you cross multiply their charges, it becomes Li3N. Now if I make Li is very easy to make because like lithium is 7 and 3, so it's 2, 1, and the lithium ion will be only 2. So if this is lithium and this is the duplet of lithium, it just has 2 electrons in its outer shell with a plus charge. Now I need 3 of lithiums, because nitrogen needs 3 electrons and lithium only loses 1. So to balance off 1 nitrogen, I need 3 lithiums. I'll have to make 3 lithiums. So the short form of this dot and cross diagram will be, instead of making 3 lithium ions, which will be a very tedious job, I will just put a 3 in front of lithium. And I can just make a nitrogen over here. This is my nitrogen atom. This is my duplet of nitrogen with crosses, dots. And then nitrogen 2, and then 5 of its own electrons, and then 3 electrons are coming from lithium with a charge of 3 minus. Keep in mind that while writing the charge, you write the number first, and the sign later. So 3 minus, 2 plus, 1 minus. You can keep on practicing about the dot and cross diagram of these following compounds. So you can make dot and cross diagrams for magnesium chloride, sodium fluoride, potassium iodide, etc. This is it for today's video. In the next video, we're going to look at the structure and the properties of ionic compounds. Till then, thank you everyone.